Yeah, so I wanted to today tell you, well, Andrew actually just kind of told me like, what have you been dealing with in tech, and um, maybe just kind of give a talk about something you're interested in. So um, today I'm going to talk a little bit about the evolution of APIs. Andrew, you can see my screen, right?
Yeah, I can see it.
Okay, great. Um, yeah, so as Andrew mentioned, my name is Mikio. I've been working in the industry for about 12 years and got an undergraduate degree in computer engineering, so both hardware and software. But I've kind of evolved into um, what people say is full stack developer, and I really like this picture of what that means. What it means is, I'm really good at certain parts of the stack, maybe, but I can also dive into other parts. So I always like this description, image of what a full stack developer is. So I'm definitely heavy on the front end side, but I definitely can dive into the back end. Some people like the term T-shaped developer as well, but that's my background. Um, so first, I wanted to talk a little bit about what is an API. And feel free to interrupt me at any time if you have any questions about any of the steps. But um, so the way that I like to think about an API, and just to clarify what API stands for, it refers to Application Programming Interface. But I like to think about it as just the way that two pieces of software talk to each other. And there has to be some sort of protocol and some sort of data being transferred between those two. And when you have an API between two things, you inherently have a certain sort of coupling. So one has to evolve alongside the other and kind of make sure that those two things are always interoperable. Um, so APIs can refer to a lot of different things. Obviously, it can refer to within a piece of software. You can say, if you're calling a module, that is an API. You could say there's server to server communication and there's an API there. But typically in my line of work with the web, people are referring to an API as the way that you communicate with a backend, whether or not that's a mobile application or that's a website. So today we're going to kind of talk a little bit more about uh, how the API between so-called front ends have developed over time. And this is kind of a designation of what an image of a typical three-tier architecture of some very small scale application. So if you're building a mobile application, you might have a mobile app, you might have a server that does a bunch of back-end business logic, and you probably want to store off the data in some sort of database. So over the years, from the 90s to the 2000s, there's been a lot of different flavors of APIs. Some of them, there's RPC, which stands for Remote Procedure Calls. There's some legacy applications, or I guess it's still currently used, but there's a protocol called SOAP. And then one of the prevalent ones is called REST. I forgot what the acronym exactly stands for right now. It's like representational. Sorry, I'm forgetting right now, but I'll go into a little bit of the details. So there's a lot of REST APIs. And in order to kind of understand the evolution of REST, you kind of have to understand how the web developed. So the web developed as an intranet or an internet on college campuses. And typically, when the web was first developed, you just would basically get a page that would be just some HTML and CSS, and it would give you a document. And so that's why that was basically the origin of the web, is just these documents, and then there was these hyperlinks between them that would kind of connect those things. So that's where HTTP was developed, and it was kind of a simple model. But as time evolved, these front ends became kind of more and more complex, and building out full-blown applications. And so just requesting the page wasn't enough. You would, intermittently want to get, was there a question, or? I think we're good. Okay, so for example, you might want to load the page, but then you might programmatically load more information, like maybe there's a list of items, maybe they wouldn't have the permissions to do that, or maybe you're creating a to-do app and you want to delete an item dynamically. And so a lot of communication started happening once the page was loaded. And so these types of requests are called AJAX requests, or they're also called XHR requests. AJAX stands for, I believe, asynchronous JavaScript, something along those lines. And XHR stands for XML HTTP requests. Just to kind of demonstrate what that is, I'll come out of here. Let's go to something like ESPN. So what you can do when if you have developer tools installed, or you're just using something like Chrome, you can come over to what's called the network tab, and you can see all. So if we refresh the page, you'll see that the initial page comes in, and then there's a ton more data being pulled in. And you can actually filter this by XHR, which I mentioned is XML HTTP requests. And you can see that a lot of content is being dynamically pulled in. So this website is kind of a more of an application rather than just a document. There's things dynamically being fetched as you scroll and interact with the website. So I'm going to go back to my slides here. So specifically with REST APIs, you rely on these fundamental concepts of a verb, a route, and an associated data payload that you're sending over the wire. So typically when you're interacting with a REST endpoint, you're trying to do fundamental CRUD operations. And what CRUD operations stands for is create, read, update, delete. And those correspond to an HTTP verb. So if you, let me open it back up again. If you go back here, and I'll refresh the page again, you'll see that each one of these has a request method. So that's what I'm talking about with the HTTP verb. It has some associated payload. Sometimes there is data, sometimes there's not. This is a GET request, so there is not an associated payload. And then the server is responding with a status code of some shape or form. So here would be an example of maybe you're creating a shopping cart or a to-do list. You would make an HTTP GET request to a /items endpoint. You may send a request to post. So post typically refers to creating an item. So it refers to the C in CRUD. So if you wanted to add an item, you would post, an egg to the items. You also might want to replace a specific one. So typically when you're storing something in a database, you'd have an ID. If you completely wanted to replace that item, so maybe I want to relabel the second item as milk, I could do a put request of 2 and change that to milk. There's also an edit functionality. So this is typically called an HTTP patch. So I want to update the second item. So you would say replace the name with cake, and that would make that item cake. And then you might fully want to delete that item, in which case you would invoke a delete request. And as I mentioned, there's a bunch of status codes. So, they range all the way from the 100s to the 500s, and each one corresponds to, a very specific error. You can look these up yourself if you have time, but the first number refers to the type of error. So typically the successful ones are in the 200s, the ones that, the client needs to handle appropriately are in the 400s. And if the server, for example, can't handle your payload, it's in the 500s. So I'm going to play around with the REST API. You can follow along if you like, but so if you open your browser, and this is interactive, so you can just watch if you'd like, or you can follow along as well. And also let me know, Andrew, if this is too small. But this is an example of a REST API. And if you're familiar with curl, you can interact with this. So for example, let's try it out. So we'll do curl. And if you're unfamiliar with curl, the $X refers to the HTTP verb. So we're going to do a GET request. You also typically want to set a header to say the type of content you support. So content type application JSON.
Can you make your terminal just slightly bigger?
Yeah. How's that, Andrew? Does that work?
That's good. Thank you.
Okay. And then you send in the route. So let's see. This is a HTTPS, which is the protocol. Star Wars API. Dev API. People 68.
Sorry, I need it to be zoomed a little more because I just can't read it.
Sure.
Sorry about that.
And I'll put it in the center of the screen. How about that?
Yeah.
So I'm making a curl request, which is basically the same as an XHR. This is what's happening under the hood. And I might have put a typo in. Application JSON. Let's see, what am I doing wrong here? Getting the man page for curl. Let's see. Clear that again and see what I'm doing wrong. Curl -x get header content type application JSON. Oh, maybe it. Oh, it is printing out. Sorry. Is it? Let me see if you can just copy the curl. You can. Let me remove the header and see if I'm typing it incorrect. There we go. So I can just omit it. I'm going to pipe this to JQ, which is just a pretty printing of JSON. But here you see we're getting this person. So you can change the ID of the person. And the first one is Luke Skywalker. And you can see that it also has references to other things that this person might be involved with. So like Luke Skywalker was in, the first, second, third, and sixth film. Luke Skywalker apparently rode Vehicle 14 and 30, and also was on Starship 12 and 22. So you can kind of see how data is linked, even though it's kind of just giving you the detail of Luke Skywalker. And if you, for example, wanted to do other things like add a user or a person, you could change this to a post and interact with that. So hopefully you get a good sense of how REST APIs work. But I now want to focus on kind of how that breaks down. So a lot of applications still and to this day use REST APIs, but the number of clients has drastically kind of exploded, right? So if you think about something like a Facebook.com or something, you have a mobile app, you have an Android app, you have the website, and then you also might have third-party APIs. So thinking about a company like Stripe or GitHub, you might use the GitHub API to programmatically do things as well. And so an API gets vastly complicated because it has to satisfy all these different use cases. Also, you can kind of imagine that APIs get very complicated because with what you just saw, and you're just getting a bunch of people, for example, the use cases might vary depending on whether or not you're building the Android app or you're building the web app. So you might want, on the mobile app, you might only want to display 10 at a time. So you might have to support pagination saying, you know, page through the data, just give me 10 at a time. Or for a mobile app, you might want to sort the Star Wars characters in alphabetical order, versus on some other application, you might want to sort it by chronological order or something else. And then additionally, you might have to do some sort of filtering. So, you know, give me all the Star Wars character that, you know, pass away, are dead currently, or just, you can imagine that these APIs get more and more complicated, and it's pretty hard to kind of keep track of everything that you need to do. And in addition to that, since you're trying to evolve this API alongside these clients, you might have to introduce versioning. So for example, maybe you're trying to beta test something new on your mobile app that you don't want exposed to the web. So you might have to support version 2 for this one, and then also support version 3, things of that nature. And here's an example of the reason why REST endpoints really started to break down. So if you're unfamiliar, Facebook was one of the first companies to kind of create these really complicated UIs that had a bunch of different requirements, and specifically the news feed. So if you look at the news feed, it's not just a list of posts. Sometimes it's somebody uploaded an image. Sometimes it's somebody's birthday. There's like a non-homogeneous set of data being displayed. And if you were thinking about how that's displayed and kind of what we saw with the REST endpoints, you can imagine how complicated that could be. So you, for example, might have to say, who am I? Just to identify your information. Then you might have to go get all the posts. And for each post, you might have to get the comments. And for each comments, you might have to retrieve the reactions. You can see kind of how the number of requests that you have to make would kind of blow up very, very rapidly if you were just using traditional REST protocols. So one thing you might do is introduce a very specific endpoint that just supports the newsfeed. But that is not really ideal, because kind of the things that we mentioned before, like versioning and querying, you have to bake that in, and you're basically pushing all the front end requirements down into the server. So another thing to note is with Star Wars API, for example, you could see that data is not really organized in flat lists. So, you know, when you're looking at a bunch of characters, you might care about their the films that they're in. Well, in this case, you know, if you're creating like a Netflix, you might have movies, and those have a cast members, and each one of those cast members is people. But you might not always want to look at the data from the perspective of movies. You might want to know all the movies that the people are in. And so you have to constantly be linking these two lists together. And that can kind of, that data model doesn't really translate with REST. And so that's where GraphQL comes into play, and is kind of the current latest and greatest evolution of APIs in terms of front-end development. So what the smart people at Facebook realize is, why don't we let the client basically ask for what they want, exactly in the shape that they desire. So for example, maybe you're creating an application that shows a bunch of movies. So if you have an API, you could basically design out the data that you would want, right? So you could say, I want a list of movies. For each movie, I want the name of the movie, and I want a list of the directors. So in this case, George Lucas. If you were doing this with a traditional REST endpoint, you would have to force the /movies API to support directors. And maybe that's not something that everybody wants, right? So maybe the mobile app shows the director, but maybe the website does not. So in a traditional REST endpoint, what you end up doing is what's called overfetching, because you have to satisfy every use case. But with what GraphQL lets you do is basically say, this is the shape of the data that I want. And you can just remove the parts of the data that is the values that you want to be fetched and provide a textual representation. So if you're familiar with this is with JSON, GraphQL is a querying language that kind of looks like JSON without the values filled in. So here's an example of a GraphQL query, is that you say, I want the movies. For each movie, I want a name. And for each movie, give me the directors and their name as well. And the great part of GraphQL is you can invert that query as well. So maybe you want to show all the movies that a director has directed. So you can switch that around and say, give me all the directors, and within that, give me all the movies that director has worked on. Hopefully I'm not going too fast, but we'll play around with one really soon. So I mentioned earlier that usually when you're dealing with an API, you're performing what's called CRUD operations. So creating, reading, updating, and deleting the data. And you also might be working with live data. So you might have WebSockets proactively giving you more information being pushed from the server to the client. So with traditional CRUD operations, the reading or the GET requests translates to what's called a GraphQL query. And for other things like updating, deleting, and creating, all those get lumped into one thing called a mutation, because you're basically changing the data that's stored in the server. And then specifically for the push and long polling, it introduces this concept of a subscription. So you can basically tell it the data that you are interested in, and whenever that data changes, it will push you new information about that. So it kind of reorganizes traditional APIs in these three different forms: query, mutation, and subscription. So I know that's a lot if you haven't used a GraphQL API. So let's play around with it a little bit. So if you go to starwarsapi.graph.cool, there's a GraphQL API exposing the same exact Star Wars API. How does this look, Andrew? Is it visible? Oh, that does not look good. Can you see it, Andrew?
I think that's good now.
Okay. So kind of like I mentioned, so this is a tool, it's a playground basically. And GraphQL so first I'm just gonna go over the query language. A cool thing about GraphQL, it has built-in types, so the scalars. So there's, if you are familiar with programming primitives, it's basically very simple. It has strings, ints, floats, booleans, and IDs, and a hash sign after that designates required. And so an example of a GraphQL query, this is implied, by the way. You can put the word query, but if you remove the word query, query is implied. So maybe, for example, I want all the species in Star Wars. I want their ID and name. So if I execute this, what you can see is it's basically this query, but these values filled in. So you see Yoda's species. It has, all these different species. And a cool thing about GraphQL is you actually can fire off multiple queries at once. So for example, in typical REST APIs, if you wanted to get two different lists of species, you would have to do that in two queries. But in GraphQL, I can say, I want all the first three films, and I also want the last three films in the same query. So you can basically solve the problem of multiple round trips, right? If you can imagine if you're creating an application and you're making a lot of network calls, calls, you basically incur the debt of having to make that round trip to the server and pulling that data. With GraphQL, you can do that in one go. So, oops, I have two queries open here. Comment this out. So now we see that the first three films are A New Hope, Attack of the Clones, and The Phantom Menace, and the last three, oh, sorry, I also requested the species. So this might be you're creating an application that has, you know, a bunch of movies, and you also want to put the species on the same page. You can pull those together. You can also continue to nest the data. So this is kind of what the graph traversal I was telling you about. And if you're following along, you can press Alt Spacebar, and you can basically look at everything you can pull at a specific point in your query. So I might want to see all the characters in a movie, or things of that nature. So you can reverse. What I'm trying to show you here is that you can do you can put these nest these queries in any order that you feel like. So maybe you want to look at all the species and the films that they've been in, or you can do the reverse. You can say, give me all the films and then all the species. So it gets you a lot of flexibility in the way you want to query it. You can kind of think of it as like, if you've ever done SQL or something, you're basically able to kind of create a query in the way that you want, but in me personally, a lot more intuitive way. Another thing you can do with GraphQL is you can make the same query, but with different parameters. So for example, you can imagine if these two, if I wanted to get the first Star Wars film and also the last Star Wars film, there would be a conflict between these two, right? Because if you're familiar with JSON, these would basically be the same key on the object and would probably fail, right? So it'd say all films has a conflict. So you can actually alias these. So you could say this is the first film. And you can say this is the last film. Fire this off. So the first film is A New Hope, and the last film is A Force Awakens. You can also pass in parameters. So it works a lot like a function call. So at each level, you might have specific filter values. So you might want to get the species that specifically has this ID. So maybe you're showing the details of a species. You can pass in the ID and you'll get that. But one thing you might notice that's kind of problematic with this kind of query is that this query immediately becomes not reusable, right? Like I'd have to, you know, if I wanted, this one is maybe the Jabba the Hutt species, but if I wanted to get all the Ewoks, I'd have to write up this all over again. And so what GraphQL helps you do is add parameters. And so kind of like what you would do with a function call, you can say, I'm going to name this query get species and specify a parameter that gets passed in so that I can now fetch any species details using this query over and over again. And how this works is you basically have to specify all the parameters specified here in the query variables. So now if I execute this query with the species ID listed below, we get the same information. And so now your query is reusable. But you also might be asking that, well, you know, every time I interact with species, I have to type out all these fields I care about. That's kind of painful. So GraphQL has this concept of a fragment, which is a reusable unit of information that you might want to use over and over and again. And so let's rewrite this query above here using this fragment. So every time I fetch a species, I care about its ID, its name, and its description. So now I define a small fragment of the query. And if you're familiar with JavaScript or something like that, it uses this notion of a spread operator, and you can spread the species details inside of the species. So this means that now every time I request for a species, I want the ID, name, and description. So that means that across your application, whenever you use this fragment, you get the same type. And so now you see that we get the designation as well. Want to leave some time for questions. There are a lot of other things like directives, which are ways of putting some Boolean operators or things like that. And there's also, as I mentioned, mutations and subscriptions, but I want to leave a little time for questions. I'm going to move on. There's a lot of use, I don't want to say that GraphQL is perfect and it replaces REST in every case. In fact, the vast majority of APIs out there probably still REST. If you're going to interact with a third-party service like Stripe, you're definitely going to be still having to learn REST. But some of the perks of using something like GraphQL is kind of like I mentioned, there's no overfetching. You get exactly what you request for. Kind of like what I showed you with multiple queries, you can minimize the number of round trips so you can get all the data that you want in one go. You may have noticed that there's this concept of a schema. So everything is actually pretty strongly typed, and you can even validate the request you're making even before it gets sent to the server. You don't really have to worry as much about versioning because the graph can introduce different parts of the graph. You don't have to have like a legacy version and a newer version. Sometimes maybe you do, but an example is that Facebook is still on their version 1 of GraphQL, I think maybe like 5 years later. And so versioning becomes kind of a less of an issue. It really increases the velocity of front-end development. I can't re-emphasize this one enough. Having used GraphQL versus REST, I can basically ask for whatever I want. I can build a new feature really, really rapidly because I have the entire graph at my disposal. I also want to tell you a little bit that GraphQL is not limited to client-server communication. There's a lot of interesting ways in which you can communicate with local storage. An example of a very interesting use case for GraphQL is this project called Gatsby, for example, you may have heard. It can create a GraphQL API of documents or files so that you can create really cool blogs using GraphQL. The documentation is built in, something I didn't quite get to show you in time, but you can see that when you define a schema, everything just basically automatically gets documented, and you can explore the graph really, really easily. And then you can create static types. So if you're using with Python or TypeScript, you can basically generate the types and be very, very safe, right? So because the backend exposes what it's capable of providing, you can generate types, and you get amazing developer experience of being able to have type ahead support. So, like I kind of showed you, you can just hit Alt spacebar and know everything that you can fetch at any point in the graph. Oops. All right, I want to leave some time for questions. I know I've been kind of rambling and was a little bit fast, but that was actually my first talk. So really appreciate you going through my growing pains. If you feel like reaching out to me, I do have a Twitter. But yeah, if you have any questions about what I talked about, hopefully you got a kind of a sense of when you might want to use GraphQL and why a lot of companies are adopting it. I can give you some companies off the top of my head that are currently using GraphQL. There are a lot of big ones. There's GitHub, there's Twitter, a lot of CI tools like Circle CI. Companies like that use GraphQL to great success. So with that, I'll open it up for questions.
I just want to say thanks for doing this talk, Mikhail. That was awesome.
Yeah, no worries.
We only have a couple minutes, but I do have a question.
Yeah.
Have you worked with Async.io at all? And what do you think about it?
Async.io, is that a library or is it
Yeah,
a?
it's a Python library for basically a wait sync kind of syntax where you're with communicating. For example, like I was just using Twitch's API to build a bot with integration from Spotify, and it was like I was just like building using both APIs, and I just wanted to see if you had any thoughts about it.
I don't have too much opinions on, from the Python perspective, I've only used things like Graphene, or a very good company that's doing a lot of tooling around GraphQL for different libraries is a company called Apollo. I believe there's probably an Apollo client. I'm not super familiar with asynchronous Python because I typically deal with asynchronous TypeScript or JavaScript, and it's already kind of async by default. So I don't have too much opinions about specific libraries.
Cool.
Yeah.
Not to interrupt you. So unfortunately we're on the free version of Zoom, so it's going to cut out at the 40-minute mark in like a minute here. So just rejoin the call and we can keep this going.
Okay.
I guess before we cut out, I followed along with Gatsby's free tutorial online, and
Yeah.
it was awesome. Like just to build a simple website using GraphQL is actually very intuitive, and it takes a couple hours, and you can have a working website on one of those now.shell or whatever websites. It's pretty awesome.
Yeah, Gatsby is a great one. Another free one that I recommend if you have experience with Postgres, try out Hasura. Hasura basically takes your database schema and automatically translates it into GraphQL queries. So that's a really easy way to get started as well. It's kind of like a no-code tool to just get up and running with GraphQL, and it has built